All right, next part, we'll go through 18, 19, 21. Yeah, so copper 1 phosphate. All right, so phosphate is PO4 3 minus. So to balance that out, if we have copper 1, we're going to need 3 coppers, right, to balance out the -3 charge on phosphate. So copper 1 phosphate would be Cu3PO4. Right, chromium 5 nitrate. So nitrate is -1. So if I've got chromium 5 plus, I'm going to need, right, 5 nitrates to balance that out. So that would be that one right there, CrNO3, and then 5 of those. So those two are transition metals where we need the Roman numeral to indicate the charge. And then the last one are also already matched up, right? The lithium sulfide. Sulfur is group 6, which means it's going to have a -2 charge. Lithium is group 1, so it's got a +1 charge. So we're going to need 2 lithiums to balance out the -2 on sulfide for question 18. Yeah, so Sean, they're not really equations, right? It's dimensional analysis of like, how do I go from mass to moles? How do I go from moles to molecules? How do I go from molecules to atoms? So there's no real like equation we're using for those steps. It's just kind of like, what are the unit conversions, or what do I have to go from those steps? That answers your question. All right, we'll do question 19. All right, albuterol, commonly prescribed for asthma, has the formula C13H21NO3. What is the molar mass of albuterol? All right, so for this, I even gave you, and I'll do this on the real exam, right? On the real exam, I'll tell you how much carbon is, how much hydrogen, nitrogen, right? Normally, you'd have to go to the periodic table and look these up. All right, so got 13 carbons times 12 AMU each. I have 21 hydrogens times 1 AMU each. I've got 1 nitrogen at 14, and I've got 3 oxygen at 16 AMU. All right, so 21, 14, 48, 12. This would be 120 plus. Yeah, 156. Add those all together, 156 plus 21 plus 14 plus 48. All right, I get something like 239. Well, I guess I could have used, yeah, I should have used grams per mole instead of AMU. I should have looked to see I was giving you grams per mole here. So for question 19, right, take those molar masses and then multiply by how many of each of those elements we have in the formula, add them together to get the molar mass of this compound. Yeah, molar mass, molecular mass, we're kind of using it interchangeably. So for this purpose, yeah, we can use those kind of in the same way. All right, question 21, it looks like, is next. All right, your average cup of coffee contains 115 milligrams of caffeine. How many moles of caffeine are in this cup of coffee? And so, here's one of those calculations where there's not really an equation to memorize, right? We've got milligrams. I can't do anything with milligrams other than to find grams. And once I find grams, I can find moles, right? So I've got 115 milligrams. I know in 1 gram, there's 1,000 milligrams. So we've got 0.115 grams caffeine. All right, that's step 1. Step 2, we can find moles because I gave you the molar mass, 194 grams per mole. So, okay, I've got 0.115 grams. All right, I know 1 mole of this, I would need to have 194 grams. So again, it's not an equation we have to memorize. It's just how can we put this information together in a way to solve the problem, right? So 0.115, divide that by 194, and I get 5.93 times 10 to the minus 4 moles, right? I would go with 3 significant figures because we have 3 significant figures there in the initial problem. All right, so that looks like choice C for question 21 there is the correct answer. All right. Stop the recording there.